Hi everyone, we are going to present the questions and the solutions for question 2 for our computer-based test for simulation and credibility theory module. First, let us look at the questions 2. The question given the first point is the I claim amount is denoted by X, which claim amounts can be 300, 350 or 500. Besides, the claim amount is dependent on the value of a risk parameter theta. Theta is a random variable that takes the value theta 1 with probability y plus 0.05, theta 2 with probability y plus 0.04, value theta 3 with probability y, theta 4 with probability x, value theta 5 with probability 0.3, and theta 6 with probability 0.06. Next, the conditional probability of x given theta is this, which we will be transferring it into a pie chart for better understanding. The fifth one, the random variables x given theta are conditionally independent. The Bayesian premium given is 389.9672107, which is the expected value of x7 given x1 equals to 300, x2 equals to 350, x3 equals to 500, x4 equals to 300, x5 equals to 300, and x6 equals to 300. Before we start, we have to prepare our brain, Microsoft Excel, coffee, and our stationery. Next, the rules is to ask permission first when you want to leave the video, and the objective of this video is to get the 550 ringgit of the book voucher sponsored by Juris Tech. Let's transform data into a pie chart first. So these are the pie chart of probability of x given theta 1, theta 2, theta 3, theta 4, theta 5, and theta 6. Before we start, we need to know about what is Bayes' theorem. Basically, Bayes' theorem is a mathematical formula to determine a conditional probability, and this is the general formula for Bayes' theorem. Particularly, we are using the conditional probability of event A occur given that B has occurred is equals to probability of event A and B both occur over probability of B occur. On the other hand, probability of B given A is also equals to probability of event A and B and A has occurred over probability of event A has occurred. Okay, likewise, so probability A and B is equals to probability of B and A. Basically, we are setting both of these equal. Hence, probability of A and B is equals to probability of A given B times probability of B, which is equals to probability of B given A times probability of A. Next, we are going to divide both sides with probability of B. So this is giving us a formula about Bayes' theorem, which is probability of A given B equals to probability of B given A times probability of A divided by probability of B. As a conclusion, Bayes' theorem calculates the conditional probability given the reverse conditional probability and also other probability. That's all about Bayes' theorem. Okay, after understanding the Bayes' theorem, the questions give us the Bayesian premium, which is the expected of x7 given x1 until x6, which is equals to the total of expected value of x7 given theta I times the probability of theta 1 given x1 until x6. Basically, probability of theta I given x1 until x6 is equals to C times probability of x1 until x6 given theta times the probability of theta. The C is equals to 1 over probability of x1 until x6. So after listing all the data given by the question, this is the table for for the claim amount of x given data 1 until data 6 and the probability of each data. Okay, next we calculate the probability of x1 until x6 given data I. The probability of x1 equals to 300, x2 equals to 350, x3 equals to 500, x4 equals to 300, x5 equals to 300, and x6 equals to 300 given data 1 is equals to 0 0.3 times 0 0.3 times 0 0.4 times 0 0.3 times 0 0.3, which is equals to 0.000972. This is because from the questions in the pie chart, the probability of x1 equals to 300 given data 1 is equals to 0 0.3, and the probability of x2 equals to 350 given data 1 is also equals to 0 0.3, while the probability of x equals to 500 given data 1 is 0 0.4. So we times it accordingly for data 1 until data 6 and we will get this data. So it will be very complicated for us to calculate as it involves a lot of unknown, which is the x and y. Hence, we will use Excel to solve it.
Now we are going to talk about simulation and credibility theory CBT question 2. So given by the question, this is the probability of x equals to 300, 350 and 500 given data equals to 1 to 6. So for example, the probability of x equals to 300 given data equals to 1 is 0.3. The probability of x equals to 350 given data equals to 1 is 0.3. And the probability of x equals to 500 given data equals to 1 is 0.4. The total of these three should be equals to 1. And the same for the others. According to the question, this is the probability of each data. So the probability of data equals to 1 is y plus 0.05. And the probability of data equals to 2 is y plus 0.04 and so on. So we are asked to find what is x and y. So first we will assume that we already know the number here, what is y. So if we already know what is y, so we know that this is equals to y plus 0.05. And this will be equals to y plus 0.04. And this will be the y. And this is 0.023. And the last one is 0.06. And we know that the total of these 6 should be equals to 1. So we can write here, x is equals to 1 minus this, and this, and this, and this. Alright, so now we come to here, we are going to find what is expected of x7 given data equals to 1 and until 6. So expected of x7 given data is actually just the expected of x given data. So to find the expected of x given data, so we have the x value multiply with the probability. Then we plus with the x value 350 multiply with the probability and 500 multiply with the probability. And then we need to log the x value. And we drag down to get the value for the others. So this is the expected of x given each data. And next we will find what is the probability of x1 equals to 300, x2 equals to 350, x3 equals to 500, and x4, x5, x6 given each theta. So the probability of x1 is 300, which is given by the question, is 0.3. And according to the question, x2 is equal to 350. So the probability is 0.3. And x3 is 500, x4 is 300, and 5 is 300, 6 is 300. And so this is the probability of x1 to x6 given each theta. And next we will find what is the probability of x1 to x6 given theta 1 multiplied with probability of theta 1. So this is equals to what we found just now and multiply with the probability of theta 1. And then we drag down for all. And so the probability of x1 to x6 is just the sum of all of this. So lastly, we need to find what is the y value so that we can get the expected of x7 given x1 to x6 equals to this. So to find this expected, we need to multiply expected of x7 given theta 1 multiply with the probability of this over the total probability and plus with the second theta multiply with the second theta over the total and plus with and so on. So alternatively, we can also do, if we don't want type 1 by 1, then we can also do like this. So we multiply this with the probability over the total. So the total is actually 1 over C. So means that multiply C, so means that divide this probability. And then we log this. And we drag down to get 6 theta value. And we sum them up. So we get 365.0635, but what we want is 389.9672107. So we can use solver to solve this. So from data, we can get the solver. So the objective is I want that this equals to, I want this to be equals to 389.9672107 by changing. So my variable is y. So I solve this and I will get the answer. So the y should be equals to approximately 0.2 so that we can get the expected is what we want. Okay, so besides the solver, we can actually also use this, which is goal seek. So this is the same function actually, but different. So we set cell this equals to 389.9672107 by changing this cell. So we will get the same thing. Alright, so our y value will be approximately 0.2 and x value will be approximately 0.02. So that's it for this question.